Hi, in previous lectures we have been using either a context-free grammar or a context-sensitive grammar to generate sentences. In this video, in addition of the study of such sentences, of the generation of sentences, or understanding when a sentence belongs to a given language, the language that is being defined by a specific grammar, we want to add some structures to capture the semantics of the sentence. In this case, the semantics represents the meaning of the sentence, and once we understand the meaning, we can take some actions after understanding the sentence. So what we really are concerned is on some knowledge structures that represent such semantics. Look at this example. What is it what we want? So this is again similar to what we were doing before with the grammars, but now we're extending that and adding some the semantics, some semantic structures to the sentences. So look, before we were using this relation in which we were parsing a sentence, and then basically we got a yes or a no, or we were querying like what will be the other words that will follow. Even we have examples about using probability and so on. In this case, X will be the knowledge structure that represents some of the semantics associated with this sentence. So in this case, the sentence that says the man likes the dog generates the following meaning. So it says that there is an action about liking, and the one that is liking is and the agent is a man. In this case, the man, the underscore 23, we don't have the name, but it's a name, and is liking an object. Or in this case, we have the definition that this is a dog. So in this case, the dog likes the man, and then here the agent, which is the dog, and is not an unknown dog, it has a name, so it's a specific dog that likes an unknown man because it's not described on the sentence. So we're following the same constraints about the grammars, and like we have before, but there are now additional constraints with the semantics. Like in this third example, look that we're getting a no, even though this is a well-formed sentence in the grammar. It doesn't qualify on the meaning described in the structures for the semantics, that the man bites the dog. So in this case, we're getting a no. Here, look that the sentence is similar to the one that I have highlighted over here. In this case, the dog with the name Fido bites the man. So in this case, we got this knowledge structure in which we got here the action, who's performing the action, and so on. So again, it's up to us how are we doing the definition of the representation of how we're going to understand the actions. And let's see some about the basics about this program. So like, for example, here on noun and verbs, we got some structures. You see here, this is something like we're gonna call like the frame, and that was one of the ways of that we studied before about knowledge representation, and a component of the frame are the slots. So in this case, you see there is action, agent, and an object. So this is an action of doing something over look that here in the part of liking, we just can be in general is not being defined on a specific type of object or noun. Like in the case that we got a verb that bites, the action has to be performed by a dog, and that's why one of the reasons of why this sentence is failing. So here we got something related with the knowledge representation of the actions that will involve these verbs associated with those nouns. Okay, so you see this looks similar to the terminals, I mean the variables that derive terminals in the grammar that we have been studying in the past videos. But look at that. Now in this example we have some knowledge structure associated with each one of those, and the main part of the code that I want you to study in this case is that, okay, we providing the sentence and we're expecting the sentence graph, which will be the representation of that knowledge. And what we need to see is that when we generate the sentence, you see here again it's the same way that we were parsing before, the noun phrase and verb phrase, but now each one of those responds with a subject, in this case with a graph, with a knowledge graph, or with a that indicates the like in the case that the verb has the actions, and then here we got the nouns. So what we need to do is that we have to join the information that is that comes from the noun phrase and the verb phrase. So you can go and look into the details about how is that we join, how is that we merge those structures until we derive at the final semantic graph. But you see here we got the same derivation of the rules. I mean, we got sentence, that is just one possible case, and then noun phrase we got two possibilities, verb phrase is again two possibilities, and then the main thing is that each one of those is getting a semantic graph that represents the meaning associated with each one of those. So the main thing is that now we want to go into merging or joining those structures and derive just one structure that represents the meaning of the whole sentence. So I think you can go and look into the sentences, I mean into the relations that do the joins, and when is that we gonna join or merge the frames, and when is that we're gonna add a slot to a frame. So I think you can go and look into those details, but the main thing is that we want to derive an answer that is, in this case, is just representing this. Again, this is a very small example that makes the representation of the semantic net parser, because I mean a good way of calling this is semantic net because of the graph structures, but semantic net and frames represents the same thing. The difference is the semantic is a more graphical representation of the frames.